Welcome back to Chris Does Rocks. We're doing a little experiment today. It's kind of a basic one, but shows some principles of physical science. Namely, the difference between a white and a black container for how much they heat up. Our materials for this are obviously a black and a white container, a grow light, currently off, 2 thermometers, alcohol, currently in a bowl of water to get them acclimated to the same temperature, because no point in starting the experiment if the results are going to be rigged from the beginning, and 1 measuring device to put the same amount of water in each of them, because, well, again, not fair to have more water in one than the other, so it takes more to heat it up. Normally we'd be using precision calibrated things like graduated cylinders in milliliter sizes, and we'd be using an ice bath and a heating bath to calibrate both the thermometers. I've already calibrated them before, and in this case, it's a huge hassle that I actually don't have time in the lab for. So, unfortunately, that one you're just going to have to trust me on. So, now that we have both thermometers to 20 degrees Celsius, we're going to fill up both of these jars. You won't see it thanks to the magic of editing, but okay, white jar gets 200 milliliters of water. Black jar gets 200 milliliters of water. And both will get a thermometer. We will give them a few minutes to come up to temperature. Okay, both of these are now at 20 degrees to match room temperature. So again, we have a similar starting point. So now we're going to turn on the light as our external heat source. And the waiting game. Okay, after about 15 minutes of standing around and waiting, which we've skipped over because, dear God, nobody wants to watch that, we have reached a new temperature here, where the white container is at almost 21 degrees Celsius. And the black container is a little over 21.5 degrees, almost 22. Okay, so what does that mean? Well, it means the heat from the light, or at least energy from the light, is hitting the containers, being absorbed, transferred to the water, and then to the thermometers. Why is it doing it in the black one more than in the white one? Well, that's because white reflects a broad range of wavelengths of light. Okay, that means it's going to absorb very little heat and very little energy from visible light. Black materials, on the other hand, absorb a wide range of frequencies and wavelengths of light. So it's just going to soak up more of the energy from the light and heat up more. Okay, another factor to consider why this is happening at this rate is that it takes approximately 42,000 joules of energy per kilogram of water to raise it 1 degree. Okay, as you recall, we put 200 milliliters in here, so that's about 1/5 of a kilogram, or 0.2. 1 kilogram, or 4,200 joules times 0.2 gives you 840 joules needed to raise 1 degree. And a joule comes out to roughly 1 watt per second. Assuming it's exactly 1 watt per second if you don't have any other factors involved. But thanks to things like air temperature, the difference in heat absorption, and the fact that this is only like a 20 watt bulb in there, yeah, you're not getting a lot of heat pumped out of here. Now, normally I would do this outside in the sun where we get a lot more energy available to pick up, but the weather's really not cooperative, so we're doing it this slow way with this tiny, tiny demonstration of 1 degree in 15 minutes. So, there you go. Fairly basic science experiment that we already kind of knew what the outcome was going to be, but it's more of an excuse to A, produce content for this channel, yay, and B, show off basic scientific principles like the difference in heat absorption, and more importantly, the use of instruments being standardized and how easy it is to go and test a lot of concepts for yourself in science. Because that's really what science is. It's not about memorizing long lists of facts and doing strange arcane math on whiteboards. It's about taking an idea and testing it to see whether that idea works. So, until next time, I guess.